Hello, so today we are going to do this problem called count negative numbers in a sorted matrix. So we have an n by n matrix grid that is sorted, and we want to that is sorted in non-increasing order. So in decreasing order for both its row-wise column and row-wise order, and for the column-wise order. And we want to return the number of negative numbers in the grid. Okay, and so for example, here in this example we have a grid that contains these values, and the negative numbers we have 8. We have this one, 2, 3, 4, 5, 6, 7, 8. And if we go down to the constraint, we have that at most we have 100 elements, and the values can be between -100 and 100. So how can we solve this problem? So if we see here the bounds are 100, I mean, we could just do a traversal, right? And then stop when we encounter, do a reversal like from the end of each row, right? And then stop when we reach a positive number, right? Because it's sorted. We could, I'm not sure if we could use the fact that it's also sorted in column, on the columns, right? So let's just try to do it in the simplest way, which would be, so we have the grid here. Let me just name it this. And we need a count variable. Then we need to go through each row, and we can go through the columns. We can do that in reverse order, so that would be length of row -1, and we want to stop at 0, and then we go down by 1. And if row j less than 0, actually if it's bigger or equal to 0, we want to break out of this row, right? Otherwise it's smaller than 0, so we should just increase count, and at the end just return count. Okay, that seems to work. Let's try it on this one, and this one, and this one. So we have at least one element in the matrix. We don't need to test the empty list case. Okay, it looks good. Let's submit. Okay, it looks good. Cool. Yeah, maybe there is a solution that uses also the fact that each column is ordered, so let's see. Interesting. So this solution uses the fact that columns are sorted. Yeah, because on the column also, when you encounter a positive number, you stop having negative numbers if you start from the last element of the column. So the trick here is how can you find these staircase indices, right? So you could start by starting from, I guess, this element. Okay, that's creative. So basically, start from here, see if it's negative, right? If it is negative, then that means that all of this is negative, right? Because the row is ordered. If it is positive, then go to the left, go to the right, and see if this one is negative or not. So going to the right means increment the column. So that's what we are doing here. And then if it is, however, negative, and let's say this one is negative, for example, in this case, then all of these are negative. So count them, and that's what we are doing here with n minus c. And we want to go up, right? Because we counted the negative values in this row. So we want to go up and check here, and do the same thing and keep doing that. And what's useful is that if this is positive, right, you could safely go to the right column, even in the row before it, because columns also are ordered. So if this is positive, that means that all the elements before it on the column are positive. And that's pretty much it. So yeah, this is a clever solution. So what you can do for that is we need to start row and column. So these would be so the first one would be length of the last row, right? So length of m minus 1, and then the column will start out as 0. Bigger than 0, and column less than or equal to, we never decrement the column, we only increment it. So let's just call this rows. Stop columns. Yep, and actually less than, okay. And then we will need to start checking the elements. So RC, if it's less than 0. Now, if it is positive, as we said, we need to, if you go back to the staircase here, if it is positive, then, so if the element is positive or equal to 0, let's say here or here, then that means we count all of, we go right? We go to the right column because we don't know where the negative values start. So that means here in this else, we need to increment the column. Now, if it is negative, then we know that all those to the right of it are negative. So we can just add these to the count. So count would be plus the number of columns minus the position of the column, right? Because it's, if we are at 1 that we find is negative, then it's n minus 1 if n is the number of columns, right? And so that's what we do here. And now we are done with this row. We can go up to the next row. We can also leave it at the same column, right? Because we know that if this is positive, this is definitely positive, right? So we could say go to the next row. Okay, actually for the row, we start from the last one, so we need to decrement. And then here, we should return count. Okay, that looks good. Okay, so that passes. Yeah, this is actually, don't use the fact that anything is sorted, right? So, which would mean here, instead of even doing like exiting when you reach a negative value, we could just count the number of negative values. So if you do this, right, whenever this is less than 0, it will be true, right? And true is considered as 1 if you give it to some, right? Because if I, let me show this quickly. Because sum of true, false would give you 1, right? Okay, what happened? Okay, let's take numbers. So let's take 1 minus 1, 2 minus 3. If I do sum of a less than 0, okay, let me just put this in a value in an array here. So this is a. So sum of a less than 0 for a in a, it should give us 2, right? So it counts how many of these are true, right? So this would mean here for a in a, and in M, right? In row, for row in M, right? And that pretty much all we need to return. So we need this first, and then okay, so this works. Yeah, I think this is it for this problem. So a couple of solutions. One of them was using just the fact that the row is sorted in decreasing order. The other one used the fact that both columns and rows are sorted, and then this solution just doesn't take advantage of that. So I would say the second one is the most useful one. Yeah.